Thanks so much for joining us, everyone, today. We got a really good crowd, which I'm really excited about. People are excited to learn about SolidWorks. Um, yeah, so the general idea of this session, we've done a full series of these kind of CAD software focused demo sessions, as we call these videos. Basically, the idea is to give everyone a basic understanding of a piece of software, the tools, the abilities it has, and how it relates vaguely to 3D printing. So we're joined today by Rob Maldonado, a certified SolidWorks trainer who is doing some really cool stuff. Also, just recently a Formlabs printer owner, so he may provide some of his experiences as he's gotten started with that process as well. Just want to mention, please throughout the session use the Q&A button at the bottom of your chat window. I'll be monitoring it while Rob is giving his presentation. If the question is about what he's working on, I'll hop in if it makes sense. Otherwise, we'll have plenty of time for Q&A at the end. We usually have 20-25 minutes or so to go through that. The chat's great as well. I'll do my best to keep an eye on chat, but it's easier for me to keep track of and monitor questions and get them out of the way as they come in if you use that Q&A button. So default to there, but like I said, I'll be keeping an eye on chat just to make sure I'm not missing anything. And lastly, just wanted to give a quick FYI, which might be, there we go. This Thursday at 12 p.m. Eastern, we're starting a new video series called the Formlabs Community Roundup. The idea of this is pretty simple, just a pretty casual stream on our YouTube channel involving a bunch of news about what Formlabs is up to, where we've been in terms of shows, what products we're releasing, what products are coming up, interviews with Formlabs employees, time for Q&A, all sorts of cool stuff. So you'll see a YouTube link there. I don't expect anyone to type that in. I'll make sure to throw it into the chat window as well, so we don't lose track of it. But yeah, I'd love to see you there. You can set a reminder on YouTube so it'll let you know when I go live later this week. It'll be great. I'm really excited, and I'd love to see you guys there. With that, I'm gonna stop sharing my screen and hide my video and mute myself, and I'll pass it off to Rob. And Rob, thanks so much for joining us, and take it away.
Excellent. So let's share my screen over here, so y'all should be able to see what I've got going on. Let's see if I can pull up the chat, perhaps. Yes, no, maybe so. Well, Dan will let me know. So let's go ahead and talk about some SolidWorks, right? So thank you so much for being here. We have a fantastic crowd in the chat. I was reading some of your hello. So hello to everyone in the chat. I see we have people from all over the world, and that is awesome. So here I'm just going to give like a very high level overview, like bird's eye view rundown of how I use SolidWorks for 3D printing, but also some other fun stuff too. I'll tell you about my personal project here, hashtag CADModelOfTheDay, and how I use SolidWorks to power it. So with that, who's this presentation for? This is for beginners. Anyone who's really interested in 3D modeling. Maybe you've modeled in some other program before, maybe Autodesk Fusion 360, maybe Inventor, maybe Blender, Cinema 4D, anyone? So yeah, this is going to be like very high level, beginner focused. Yeah, not a step-by-step tutorial like it says. Like it would take a long time for me to show you all the things that SolidWorks can do. Basically, we're answering the question, what is SolidWorks and why is it good for 3D printed models? And of course, like I mentioned before, feel free to hop in with questions whenever you get it. So, a little about me. I've been using SolidWorks since 2015 when I was still in college. I became a certified SolidWorks expert a year after. It's a certification that you basically you take a test. It's about 3 hours long, and they give you all sorts of modeling challenges. Only about 4,000 people in the world have this certification. So if you ever see one, be sure to give them the thumbs up of like, hey, you know how to do a thing. I taught SolidWorks officially with a SolidWorks reseller. So that's the elite application engineer. So I taught SolidWorks sanctioned classes with official SolidWorks material. And I did that for 2 years. So I've worked with all sorts of students from all over the place. And then my biggest project, where you may know me before, if you've heard of me before, I started my hashtag CAD Model of the Day project in 2019. So really quick, so what is CAD Model of the Day? Well, basically, it's a daily project that I started last year. And basically, the name of the game is I make a CAD deliverable every single day. You know, this screenshot's a little bit old because you see day 20. I think today's number 465, maybe 66, something like that. I haven't done it yet, so I'll do that later. But I make a deliverable, as in I model something, and then sometimes I'll do a screenshot, sometimes I'll do an animation, sometimes I'll 3D print something. It's just kind of what I'm feeling in the day. And the point of it is just to have fun, you know, teach people something they haven't learned about SolidWorks or 3D modeling. And if you're interested in seeing more from that, you know, follow me on my my social medias. You can find me on YouTube. Sometimes I live stream Virtual Flat CAD, Twitter, Instagram at Virtual Flat CAD. My Discord. I have a community Discord where, you know, I have a handful of people that like to talk to each other, not only about CAD, but other stuff too, something they're working on. It's really cool. And if you want to add me on LinkedIn or to see any other social media I have, you can find it under Linktree/virtualflat there for an exhaustive list of my social media. But enough about me. Let's get to SolidWorks. So you may have heard of SolidWorks. What makes SolidWorks special? Well, it's a 3D modeling program. Well, duh, right? But you know what differentiates SolidWorks from other programs like the ones I mentioned before, like Blender, Cinema 4D, etc.? Well, it's this thing. It's parametric. And parametric meaning that you basically enter parameters. You can enter dimensions, relationships to drive how your model shapes. So instead of, like, you know, getting a clay blob and like kind of pulling stuff here and there, here, as we'll see in a second, we basically draw 2D profiles, and with those 2D profiles, we turn them into 3D, and we can do all sorts of fancy stuff. Additionally, you basically put models together like Legos pretty much. So it's feature-based, one feature at a time. And most of all, SolidWorks specializes in making models that exist in the real world. This is important because sometimes SolidWorks will try and guide you in the way of making things that are possible to realize in the real world. And you might be saying, well, yeah, that's the whole point, right? But, you know, you take something like, for example, Blender, and Blender lets you do a lot of cool stuff because, you know, people use it to make animations and video games and other cool stuff like that. So you can get away with using other techniques. Like, I know, like in Pokemon on the Nintendo 64, like if you get a model of Charizard, which you can find on some sites, like his wings are like infinitely thin and they just put a texture on it. But you can't have anything infinitely thin. So SolidWorks will say, hey, you should probably give that a thickness. But, you know, I digress. I just want to, let's get into kind of like a basic part with SolidWorks. So we're just going to start here. So that is a picture of Abraham Lincoln, and, you know, let's just model his stovepipe top hat. I think that'll be kind of fun. So let's get into SolidWorks over here. I'll begin a new part for us, and yeah, I'm going to be kind of going a little bit quick because I got some stuff to show you. But basically, like I said, to make a stovepipe hat, you know, maybe I want to start with a cylinder, but you have to think about basically cross sections and silhouettes. So the cross section of a cylinder is, of course, a circle. So we can, for example, draw a circle centered about, well, the center there. And here's what makes SolidWorks different from a lot of other general 3D modelers. You can actually put dimensions and assign values to it. And I don't know what the size of a hat is, maybe 8 inches in diameter. Yeah, sorry for the international folks. I saw there's a lot of international things, but I like using inches, so yeah, whatever. Yeah, that's kind of big for a head, you know, it was maybe for my head, my big fat head. And from there, we can basically toss it to another command called an extrusion. And what an extrusion does, like if you imagine this is like a hula hoop, and it's like a magic hula hoop that if you move through the air, basically all the air that goes through turns into solid material. That's basically what an extrusion is. So yeah, you can see I can drag this and make this any height I want. But what I can do here is, well, use my engineering parameter knowledge and say, hey, maybe I want to relate the height of his top hat to the diameter. So if it's smaller, it'll get shorter. So what I can say here is say that this is equals, and I'm putting an equal sign in there. It equals this dimension, if it'll let me pick. Oh, there it goes, and maybe times 2. So it should be twice, the height should be twice that of the diameter. So we hit OK, and now we have a cylinder. So in other basic modelers, they might even give you like a cylinder to just kind of click and drag and you're kind of done. But what's really cool about this is that if you change your mind, it's like, well, it turns out I have a smaller head. So what I can do is, well, I can double click to change. And when I do that, you can see it actually gets a little bit shorter. So I'll change that back to its original value. You see, so the cylinder always stays proportional, which is very cool. So doesn't look very hat-like. So maybe I want to make like a brim or something like that. So I can draw another circle like that, give it another dimension. And I always want to make sure that it has a brim, that if I resize it, it doesn't lose its brim for any reason. So what I can say is, well, use its parameter-driven knowledge to, well, drive it. So maybe I want to say that it equals this dimension, maybe plus 4. So it'll have a 2-inch brim on each side. So that is now related to each other. And I can feed it to another extrusion, maybe something like that. There we go. It's a bit on the tall side, I admit, but some of you may notice another issue with this is, well, if I turn this upside down, I can't really put it on if there's no hole here, right? So, well, you're thinking, well, I need to draw yet another circle and then cut away some material. Well, the advantage that SolidWorks has over, again, other generic modelers is it actually keeps track of the surface data of each of these, each of these surfaces that I put in. So you can see that this is like a cylinder, and I can give it a command that says, hey, would you mind like making this just a consistent wall thickness? Yeah, just make like an inner surface with like a slightly smaller cylinder, and then turn all the inside stuff into air. So in SolidWorks, that's this shell command here. You just turn something into a shell. And with just one click later, you can see that the hat is now hollow. So there you go. And that's basically the technique of SolidWorks. You're taking 2D profiles and then feeding them to these commands, which turn them into 3D. And that way, it's actually it may seem like more steps, but it's more easy to control. And actually, we can even see, let's try and change it here. So let's say this is for a really fat head. If I double click that, it's going up, and maybe I change that to 12. You can see that even though I changed it, the brim knows to change, and the hat gets taller still. And I think that's just really cool. So I just want to pause here and look at some of the questions. So what is a certification name? How to get certified? Awesome question. And looks like Jody might have jumped in with the answer there, but yeah, certified SolidWorks expert. It's actually the last of the customer certification. So you can't just hop into expert. You have to take the professional exam first, which is, basically an easier version, but, still, you get some clout if you pass it. And then you can do some specialist exams with like surfacing, weldments. Like there's other packages within SolidWorks, and then you work your way up to expert. Typically takes a couple years. How would you describe the difference between CATIA and SolidWorks? Another great question. I consider them like sister software. So CATIA is parametric based, and it also it also keeps track of surface data. So if you have CATIA, that's another fantastic option for doing any of this stuff. This bro says, using SolidWorks 2019, SolidWorks does not manipulate mesh bodies very well. Do you find this to be true? That is a fantastic question. And if I may digress for just a second, I actually made an entire presentation. I made an entire presentation about that. So if you go to my YouTube channel, Virtual Flat CAD, I'll just put this over here. Okay, that was my, also I have, so basically I'll talk about these presentations later on in the video. This is from the yearly SolidWorks conference. So here I did a presentation on certification. So to answer that, you can give this a watch. And then here I gave another presentation, essential techniques to reverse engineer and edit mesh files. It's a lot better in 2020. I will say that. How did it know to break through the bottom but not the top? These are great questions. Y'all are a great crowd. And yeah, I kind of glossed over it, but it's basically with this selection here within the shell. Basically any face that I click will disappear pretty much. So if I want the top to be open, I can click this and hit OK. And now you can see through to the other side. Yeah, and I think that's basically it. Yeah, great round of questions, guys. Keep them coming. So yeah, with that, that's pretty much all I wanted to show with the little top hat. It's just kind of like a cheeky little overview. But let me see if I can get back to my presentation here. And yeah. So let's take a look at something cooler. So this was from my CAD Model of the Day project. So I like to do a lot of animations. And if you're interested in this kind of stuff, I am doing a presentation about animations this year. I haven't done it yet. And I'll talk a little bit more about that at the end. But let's take a look at how I use parametric modeling to get something like this done. So to get, let's go get this. All right, so I'm not going to go through every step because it'll take a little bit too long, but I will show you how I got like the very first sketch going. So basically what I wanted to do is, well, SolidWorks has kind of this toolbox here that has all sorts of neat little things you can import into your designs. So if I go to power transmission, there's like gears that I can click and drag and import. But before I did that, this square gear, my technique to do this was, well, the square has rounded corners, and I basically wanted the length of this rounded corner to be the same as this straight section. So it's basically when a corner comes into contact here, it'll roll along the straight edge, just like a rack and pinion pretty much. But I needed to make sure that they're both the same length. And it's kind of tough to do, but well, I mean, I kind of spoiled the answer for you there. So it's, I can draw this geometry out just like I drew the circle, but then I can say that this is a certain length. And then SolidWorks has all sorts of stuff to measure the geometry you have there. So it's keeping all that data in there. So if I click the endpoints of this and then the arc itself, you get an arc length dimension. And, the astute among you will notice that that is pi. And, that makes sense because, well, this is a circular arc. But, if you have some other weird dimension, it may not be that obvious. But then I can say, well, this straight section should be equal to this arc length. And that's how I make sure that the square gear is the right shape for my design. Then I import, a rack and some other stuff. And I do some manipulations. I might go into more detail if we have time, but I'm just going to gloss over it. But it's kind of using the same thing, drawing profiles, getting things into the right place, et cetera, et cetera. But let's say that, you have this gear now. Maybe someone gave it to you. Maybe you didn't even model it. But, someone gives it to you and says, hey, Rob, why don't you print this on your Form 3? I will say, wait a minute. How do we know if this works? I don't want to waste resin if I don't know if this works. So one of the cool things you can do with SolidWorks is, well, design validation. So wouldn't it be cool to see that, well, the square gears actually work? So, what's one of the things you can do is you can actually go into a different environment called an assembly, where you can get more than one parts or copy of parts. You can have different ones in here. You can, kind of copy it like that and move it wherever you want. But for this one, I've placed these two gears that are kind of spinning. They're not really interacting with each other, but we'll fix that in a sec. But they're kind of spinning about their own like axis there. I can actually, in SolidWorks, go to a motion study and compute a motion analysis with solid body contact. So these two bodies will push against each other and we can see, will it bind or if it'll go. So if I play this, we can see it works pretty good. So, this would get the little stamp of approval from me, just as long as we don't print it out too big. We still want to be conservative with our materials, right? But it's very cool that you can validate your design before getting into physical testing. Keenan says, can you share your SolidWorks part for your gear? Sure. Just reach out to me by direct message through Instagram or Twitter. I don't post these publicly because, a lot of people try to steal my my designs, but I'm happy to share with anyone that is trying to further their education.
Got a quick question for you, Rob, about this one.
Yeah, sure. What's that?
So with these two gears, are you only choosing to spin one and that spins the other, or are you choosing to spin both?
Ooh, great question. Thank you for chiming in there.
Yeah.
I'm only spinning one, and through solid body contact, it spins the other. So if you check this out, like you can see kind of how this is set up here. If I turn off solid body contact and just have this one rotary motor, which I can go. So I'm spinning the left gear, which is affecting the right. So if I turn that off and then hit calculate, you see nothing happens. But what is even more evident, so I'll show you something real cool here. So let me turn back solid body contact and recalculate. So some of you in the chat may know this. If this is spinning at a constant rate, is the one on the right spinning at a constant rate? If the basically the effective gear ratio is changing, and the answer is no. If this one is spinning at a constant rate, then this one is speeding up and slowing down. And one of the cool things you can do with SolidWorks is, well, you can actually measure that. So let's say I measure, get that out of there, see if it can do that. Hit OK. It's a little crunchy. Well, that's to be expected because every one of these changes is when another tooth comes into play. So if I play that, it's a little bit jittery. Guess it doesn't like me sharing. Guess it doesn't like me sharing and and calculating at the same time. But yeah, you can see that this gear is speeding up and slowing down as this one drives it. So lots of cool stuff you can do with SolidWorks. So DM chiming in, why are the teeth of the gears different? Because for the straight portions, I stole it directly. I stole basically the profile directly from a rack, and the corners are from a spur gear. So they're actually the same modulus. They're just different because one is a rack and the other is trying to approximate involute teeth, if that makes any sense. So, but yeah, just scratching the surface on a lot of the cool stuff you can accomplish here. So yeah, so that's that. Another cool thing. So we saw two gears in a single assembly affecting each other. So it's especially helpful when you're trying to keep track of parts for your build. So I animated this one too, but I'm a little less worried about the animation. And yeah, you can see I have this little Lego alien dude. And let's say, I wanted to purchase the parts individually from Lego. I mean, this is one of their designs, but that's beside the point. It would be nice to have like a shopping list of parts to have. Well, that's again something that SolidWorks keeps track of. So if I go to insert table, you can insert a bill of materials. And let's just say, just put it right here. And we have this empty description column. So let's get rid of that. And well, I mean, the table needs some formatting, but you can see for a 2x3 flat, we need one of them. For a flat 1x2, we need two, so on and so forth. So you can actually use it like as a shopping list pretty much if you needed to procure all of the parts for this. And it's pretty cool that you can even like kind of click on it. It's like, oh, what are the teeth? I mean, it's kind of obvious, but you can open it, look at it, check it out. So basically the point of SolidWorks is just not only to have 3D models in existence, but to interrogate the 3D models to get all sorts of information about it, because that's what makes an engineer's job easier, is knowing these sorts of things, because you don't want to spend your time manually counting parts, right? All right, so that's what I wanted to show with that. But another cool thing, get back into here. Another cool thing is, well, one of the things that I do most often on my CAD model of the day project is reverse engineering, which is basically having a physical model of something in real life and then getting a 3D model to, again, interrogate it in all sorts of different ways. So you can see this is an iPhone 12 mini. It's the one that I have right here. And it can be worth it to basically digitize this model into SolidWorks. And I'll speak on a little bit of how I did that. It's pretty straightforward, but yeah, there's our iPhone. Woohoo. So, why would something like this be useful? Well, what if you wanted to make, I don't know, a phone case, and you needed to make sure that the cutouts for ports were in the right place? So, what I'll do, and I'll just keep this real simple. It'll be a pretty ugly phone case, but whatever, I'll get the point across. Just get like a rectangular thing there. And looks like I did this one in millimeters. So let's do that. Maybe 140. Like that. It's a little uneven, but this is just a demonstration. So, this is going to be our phone case. It's got these sharp corners to dig into your hand and make sure you don't drop it. I'm just kidding, of course. I would put a little bit more effort into this. But yeah, you can see that there's like this rectangular block and this phone just kind of sitting inside of it. But a cool thing you can do is you can actually get multiple solids to interact with each other. So there's a command in SolidWorks called combine, and within that is a function to subtract. So I could say, we take that block and I want to subtract the phone away from it. And looks like there's a floating body over here. That's fine. But basically what you see is that we now have perfectly phone-shaped imprints, basically phone-shaped imprints into this block, and I can affect it a lot easier. So, of course, you would want the cameras to stick out of there. So maybe I would sketch and say, I want to cut all the way through like this. Looks like I'm missing some other bodies as well. Yeah, there's a little bit of like cleanup to do, but you could see how you can work on this and basically get a design and be able to reference off of it. So DM chiming in, you did the reverse engineering pictures on SolidWorks? So I guess I think what you mean by that, and feel free to correct me if I'm wrong, it's like, are you asking if I use the picture to reverse engineer in basically in SolidWorks? You can import pictures, and a lot of the times I do that. But for this one, I actually just used a set of calipers, and that's what I wanted to show in my next thing over here. So here's why reverse engineering is useful. So let's see. Yeah, so let's see a little bit of how I do it. So I have a handful of tools. I have micrometer. Of course I have like tape measures and stuff like that. But if you told me that I could only keep one tool, it would be these, a set of calipers. So there are a couple different kinds, like the ones pictured in the slide and in my hand right here, dial calipers. There's digital calipers as well. Those are just as good. I just don't feel like dealing with batteries, so I like dial calipers. You could even use vernier calipers, but those are kind of tricky to use. Really, whatever floats your boat there. Fong with a question: Do you use any 3D scanners for your projects? Great question. Not yet. Basically, at my old job, when I worked for a reseller, there was a 3D scanner by 3D Systems that we had there, and it was all right. One of the notable things is like it cost like $20,000, and I could barely get time with it. And I think that's just my issue with 3D scanners right now. It's like there's not a lot of accessible options. Though I have seen stuff where you like use your phone, and with the iPhone 12 Pro, I think comes with LiDAR, which apparently has that capability. I probably will get there in the future, but I've just been doing it kind of the old-fashioned way for right now. But yeah, calipers, why are they so good? Well, with one end, you can grab outer dimensions. Like if I get my finger like that, there you go. You can get inner dimensions with this. So that's pretty much the normal stuff. A little bit less frequently used is you can actually use this little blade that comes out to measure the depth of a hole, pretty much. So you can see that this red length is the same as this one. So if you put the bottom of the hole next to this, and on the top of the hole with this, yeah, you'll get the hole depth. And then you can even measure curvature as long as it's concave. All right, another question. Did you consider any tolerancing in dimensions? I do, and yeah, I'll get back to that question in a little bit. I just want to show you. How I can get curvature here, and then I'll go into SolidWorks and then I'll answer that question in full. But you may be wondering, how could you possibly measure curvature with calipers? And maybe someone has used this before, but I kind of came up with this technique on my own. So, since you guys been such an awesome, awesome showing, awesome crowd here, I figured I'd share my little secret with you. So, consider, takes 3 points to define a circle in space. So if we put the far end of the calipers, so this end over here, up against a a concave surface, excuse me. So that's represented in this dashed blue. So the dashed blue is what we want to try and measure. It'll eventually get to the point where the two ends will rest against the surface, and then all you have to do is, extend this blade here until it touches, and then it will give you a reading. It will give you this length. And that's actually pretty much all we need to define what the curvature is. So given that this, the overall width of your rack here, and then the distance between this first point and this second point along, I'm going to call this along the horizontal direction. So basically this line. As long as you know those two, and then you read out the third, you're able to define the radius of a curve. So I'd show you how I'll do that. So let me just begin a new part. So I'll do that, and draw a couple of it's called center lines. That is lines that are just used to help position geometry. So the overall width of the calipers, or at least my set, I actually have two sets and both are actually the same width. It's 16 millimeters. So actually, even though I have this part in inches, I can actually type 16 millimeters, and then it just does the conversion for me, which is really, really slick. And then this is 5 millimeters. So that's the overall width, and that's from the edge to the part that sticks out. So this represents this over here. 1, 2, 3, 1, 2, 3. So let's say, I take my calipers and, well, I have this guitar here. It wants to come over here. So let's say I take my calipers and I put it up against the surface like this, and I'm reading 14 thousandths. And of course, it's not the best example because the curvature is constantly changing, but pretending that this is a cylinder, but it's just generally the technique. Let's say I reach a reading of 14 thousandths. So I can put that dimension and put 0.014 for 14 thousandths. And we can get a 3-point arc and say attached to that point to this point. And I might have to click them individually like this and say make coincident. And you'll see that this appears black, which means it knows exactly its size and shape. We can get another dimension and see that it's about a radius of 3. So this technique is admittedly not very precise, but if you're trying to at least get kind of close, like I would call this a radius of 3 personally. But it's just one of the things that I thought I'd show you, and it saved my rump a couple times. So there's that. So yeah, as Dan mentioned before, I've been fortunate enough to get my hands on a Form 3, and boy, has it been fun. It really is an amazing printer, and I'm not just saying that. Like I've only had it for like a week, and I haven't spent that much time with it as much as I'd like. But I've used some of the some awesome resin. So this is the Rigid 10K. I think in all of these cases, I've just been trying out the one. But this is like an IKEA like boom box that I bought a couple months back. They give you these tiny little plastic tabs to attach them together, and they kind of got bent out of shape because I'm actually carrying this boombox like on my bike, going around my neighborhood and stuff like that just to hang out. So I printed something out a little bit more substantial, and this thing has been phenomenal performance. Here's another project that I've been doing. Again, for my bike, I'm actually working on a bike trailer right now. It's not done yet, but one of the things I needed to adapt was inner diameter of this tire that I bought from Harbor Freight, which is, you know, one of the basically the utility stores in the United States. So I got a tire here. I made a bushing to adapt it to a smaller diameter shaft, and you know, this thing just slips right in. And now I want to get back to that question: is how do you consider tolerancing with the dimensions? And that's a great question. So in terms of measurement, the calipers are accurate to plus or minus 1/1000th of an inch. So to put that in perspective, a sheet of copy paper is 4/1000th of an inch. The calipers is accurate to 1. So that's part of the issue. And what material do you use for the bushing? Rigid 10K for printed on the Form 3. So I have a feeling it'll do pretty good, but you know, I'll probably update my social media on how that works.
I'll just jump in here really quick, Rob, and mention that I'm about to post a link into the chat for the Formlabs recommended design guide. So it'll give you some recommendations on things like the maximum or minimum thickness for a wall that will the printer is able to print, or an overhang, or any of those features. So yeah, I think that's another great aspect of the tolerance question, is what can the printer handle versus what you're trying to achieve. So as long as those two things mesh, you should be fine.
Yeah, great point there, Dan. So yeah, in order to get a properly fitting part, and you know, I've learned a lot of things over the years, you know, using different sorts of 3D printers. So a source of error can come from your measurement device, though it's typically pretty little. Another is from what your printer can handle. You know, it'll have like a certain tolerance range that it can handle. And another is how you save out your SolidWorks part as STLs. So STL is a mesh file format that is made up completely of triangles. You're not allowed to have curves. So, well, I mean, if you look at my parts, those are clearly curves. So yeah, either I'm BSing you or there's something else. It's the second thing. So in order to get a curve you just get a bunch of tiny triangles. So in SolidWorks, there's actually an option to set how many triangles you want to use. So if your curves are critical and your fits are critical, you know, be sure to crank it up. Though keep in mind that that will result in larger file sizes, larger load times, larger processing, etc. So it comes with a grain of salt. So if you're just 3D printing a cube, you know, don't worry about it so much. But if you need like a specific like interference fit, and you know, you're kind of like working on that process, you know, be sure to crank up the mesh resolution on the STL. Dan, I think this one from Kent might be better suited to you. What is the resolution tolerance on the printer?
No problem. So great question, Kent. It's an interesting question. People often ask about resolution with 3D printers. That's not an applicable term really with SLA printing, especially the way Formlabs does it. But basically, it comes down to layer height, which is the Z dimension of accuracy, and the X and Y. So the X and Y is, I think, between 100 and 120, something like that, microns across. It's essentially the width of the laser beam that's doing the curing. That's your sort of XY parameter. And then in the Z, the Form 3, depending on the material you're using, has a few different options for layer height. So you have 20, 50, 25 microns, 50 microns, and 100 microns. And you can choose which one of those works best for your purposes. Generally, we recommend stick with 100. Even for a high detail part, you'll get better dimensional accuracy with 100. There are some use cases such as jewelry where you can drop it down to 25 to get really, really fine detail. But yeah, roughly 100 microns is your kind of minimum feature size, and that's the easiest way to work around.
Yeah, awesome. Yeah, it's been amazing. Translation, it's pretty amazing. Yeah, actually, I remember another question that I read. It's like, did you use carbon fiber? It's like, no, they're both the same material. I actually painted this one, so that's why the color's a little bit different.
Can you talk about how you painted it a little bit, Rob? What kind of paint did you use? Did it stick well? That sort of thing?
Oh yeah. Honestly, I think I just found like an old can of like, Rust-Oleum primer plus color, just spray paint. I just sanded it very lightly with like, I want to say it was like 220 grit, pretty fine.
Mm-hmm.
Just rough up the surface a little bit. And I think this was after one coat. I might actually give it another coat just to make it more like a deep black, but so far the finish is holding up pretty well.
Awesome.
Yeah.
I can also address that question from Fong as well.
Yeah.
But please feel free to jump into your experiences as well. But Fong, it's a great question about how to get kind of metal out of a 3D printer. A couple different options. One is use a metal 3D printer, which they exist. They tend to be quite a bit more expensive than the SLA offerings Formlabs has. Another option is electroplating, which is a process of painting a part with a conductive paint and then dropping it into a complicated acid bath with a block of metal, and the metal will move from the block to the conductive paint on the part, and you'll get a really, really beautiful thin layer of real metal on the part. We've actually done a demo session like this about electroplating. If you're interested, I'll post the link to that in a moment. And the last option is actual literal casting. You can do that if you got your own method with a way to form molds. That's fantastic. We also make a couple materials that are made for casting called Castable Wax and Castable Wax 40, or Castable and Castable Wax 40. And they are designed to be burnt out in a kiln, like a wax guide for making jewelry. So very similar process to that process that already exists. Rob, I don't know if you have anything to add on metal or if you're interested to try anything.
No, I will say it's like I do have some experience with metal 3D printing, mainly the offering from Mark Forged, where they use FDM technology to print stainless steel. But like you said, that is pretty expensive stuff, not very accessible. You need an industrial environment because you need to like soak the parts and like keep it in like an inert gas from keeping it from like oxidizing. It's really complicated. So I haven't done it yet. I am very interested in trying to cast some stuff. So I guess stay tuned. Maybe I'll try it out. Let's see.
Some of these other might be 3D printing more. If you have more of your presentation and want to get through, then we can jump into those at the end. That's totally fine.
I think that's a good idea. I only have like 2 slides left pretty much.
Perfect.
And one of the things I wanted to say was the printer has actually brought back one of my projects from the dead. I was actually telling Dan a little earlier, is like one of the things I'm passionate about is mechanical keyboards. Here I have an IBM Model M keyboard. These were manufactured a long time ago. Mine in particular is made in 1993, so it turned 27, just like me. And they're just great keyboards to type on. Very, very comfortable. Problem is they don't make them anymore. So in order to get parts, it's just basically cannibalizing other dead keyboards. So I've put a lot of effort into this reverse engineering model here. You can see here on the right, lots of fine detail. And I was just kind of pushing past the capabilities of what's possible with FDM printers, even with the high-end ones. But you can see I've printed a couple with the Formlabs, and it's done an excellent job. So I can't wait to keep testing this out. You can see it's like these are key stems, which is what actually goes into the keyboard, and on top of the key stems goes a key cap, which you can customize. It says whatever. Even the letters. I gotta clean. Even the letters I are keycaps, so you can actually take them out and replace them, clean them, do whatever. So that's one of the things that the Formlabs has done fantastically. You can see on the model on the right, you see this little bump here that interacts with a spring. It needs to be there. The FDM printer just could not make that bump for the life of it. The Formlabs could, which is amazing. So stay tuned for more of this stuff too. And whoops, where did I know I had, all right, oh, why is this hidden? From current slide? Oh, I was going to say that I'm actually presenting this year. Okay, here we go.
Oh, it might not have done a refresh after you added that slide, maybe.
Yeah, from current slide. There we go. All right, yeah. So before I wrap up and we tackle more of these questions, for 3D Experience World, which is basically the SolidWorks convention that I've presented at a number of times, I'm going to be doing a presentation on animation. So if you like that gear stuff and want to know more about it, what you can get out of it, this is the presentation for you. And because of current world events, it is completely online, free of charge. But for a limited time, it passed. They offered a VIP access, which gives you access to certain groups and gives you other kinds of fun perks. Or you could buy it for $100. But if you use my code here, 3DX21 virtual flat, you get a VIP pass to this event for free. You can see me, but you can also see basically all the SolidWorks experts from around the globe spilling their knowledge out for you to absorb. It's awesome. You should be there. No reason not to. It's free this year. So yeah, and that's all I got. So we can
Awesome.
tackle some more questions if we want.
No, that was fantastic. Rob, I did see if I can answer one. Someone asked if you wouldn't mind throwing your Instagram into the chat. So
oh yeah,
feel free to do that, and I'll answer one of these. Jay Moss asks, is there a version that's able to deal with the full build volume of the Form 3? Jay Moss, I'm not sure what you mean by version in this context. The one thing I would mention is I'm sure in SolidWorks it'd be really easy to build a sort of bounding box that has the same dimensions as the Form 3 build volume, so you know exactly what will fit and what won't during the modeling process rather than needing to find that out later. If I'm misinterpreting your question, please feel free to clarify for me so I can get that for you. Cal asks, what material in a hot mold for blow molding machine? Is that the same as vacuum molding? If it is, most of our materials should work relatively fine. I know those get hot, but not crazy hot, so the temperature shouldn't be a huge issue. Idrinil asks, can the printer compensate for errors? Great question. So the printer will compensate for errors in the process of printing, meaning that if there's some weird error in the geometry, the normals aren't facing in the right direction, that sort of stuff, our print prep software Preform will do its best to sort of find those and correct them. But there are some things it doesn't know to check for or think to check for. Some things like in SLA 3D printing, you can't do a percentage infill like you can in FDM because you're printing out of a liquid. So it defaults to 100 unless you model it as less than that, basically. Again, if I didn't quite answer your question, let me know. Here's one for you, Rob, from Bin. Did Rigid 10K leave any powder after curing for you?
Oh, that's a good question. Just a little bit. It wasn't very excessive, but after I cured it, it was covered in a fine kind of white powder. I just wiped it away, and that was just kind of that. But yeah.
Awesome. Let me see.
Yeah, I typed my Instagram URL into the chat, and
Okay.
if anything, you can Google search, my handle virtual flat CAD. It's like the opposite of virtual sharp. So if you want to remember it that way for any music nerds out there. Yeah.
Awesome. Ryan asks, and this is a good one for you, Rob. So I think he's asking, are you able to put in like tensile strength, modulus strengths of materials into SolidWorks so that you can sort of calculate based on what the resin will end up being like after printing?
Oh, that's a great question. And the answer to that is yes, with an asterisk next to it. And the reason that is, let me see if I can, resuscitate SolidWorks from here, is that SolidWorks actually does have a simulation package where you can define materials. So you can see here, it says material not specified. It's hanging for a sec. But if I go into like edit material, you can actually add custom materials. So what I would do if I was, interested in, that engineering performance, add a material just like this. And one thing like that I definitely applaud Formlabs for is that they have all their material properties easily findable on their site. So you can actually enter that stuff into here. So you can see if I pretended this phone case was made out of carbon steel, it has all of that. And then in simulation, you can, put forces, torques, pressures, etc., and run, and you'll get like a factor of safety or a maximum stress or whatever value you're most worried about, I guess.
Awesome. Got a time for, we'll do a couple more here. Go for an extra 5 minutes, not a problem. James asked, does layer height affect curing time? James, I assume you mean curing time during the print rather than curing after. Obviously, that's sort of, if you can fit it in a light box, it'll cure. The main thing that changes print time on a Formlabs printer is the height. The reason for that is the higher a print is, the more mechanical movements are involved within the printer for each layer. So, the wiper moves back and forth, those sorts of things. So the higher a print is, the longer it will take, is the short answer to that. The width and breadth affected a little bit, but not nearly as much. Here's a great one for you, Rob. Do you recommend a training program for SolidWorks?
Yeah, that's again an awesome question, and it depends on what kind of resources you have access to. Like if you're with a company that's willing to invest in SolidWorks training, going to a SolidWorks reseller for an official training course, I think would be the fastest way to get like the entire breadth of knowledge. But if you were like me, 2015, college student, broke, that kind of deal, that's less of an option. And honestly, I learned, and this actually ties into Debbie's question. She says, this is a stupid question, but how did you first get started with SolidWorks when you had no CAD experience? First, it's not a stupid question. That's the question I had back in 2015. It's a great question. And, this all ties in together. It's really about practicing, and that's basically the gist of it. That's one of the reasons I started CADModelOfTheDay is if you have the CAD software available to you, just pick stuff up around your house and say, okay, here's an iPhone. Can I model this? And you'll try to model certain things, and then you might look at this and it's like, hey, how do I get this rounded corner? And just take it one step at a time. There's a fantastic SolidWorks forum, completely free of charge. So you could say, how do you get this rounded corner? And then some person will say, it's a fillet command. This is how you do it. And that's like I was saying, that was part of the reason I lost my Instagram here. I started my whole project here. If you're looking for stuff to practice with and can't find anything around your house, just take a scroll through some of my page. Can you model these 3D glasses? So why not? And then just take it one step at a time. I think the key is practice, and yeah, I believe in you guys.
Yeah, and I'd say the main thing is also like figuring out if parametric or non-parametric is the thing for you, because that's sort of the main dividing. I learned on Maya and have been a non-parametric person for a decade. So parametric is really hard for me to get into, but I have an easier time with Blender, Fusion, Maya, that sort of stuff. 3ds Max actually more than Fusion.
Yeah, actually, I want to say that Fusion is actually another parametric, and what I want to say is if you don't have access to SolidWorks, it can be kind of pricey. I'm not going to lie. Fusion 360 is actually free for hobbyists. So what you do is you make an account, say, I'm a hobbyist that makes under 100,000 US dollars a year. And they just give you the license for a year. I think you have to renew it every year, but free of charge. You have parametric CAD, And if you have nowhere to start, I would start there, honestly. Don't let the specific brand name get you down. It's like the same thing with like woodworking. Doesn't matter what color your tools are, it's what you do with them.
Yeah. Well, cool. I think I'm going to answer one more here, and then we'll probably wrap it up, Rob. But I think if you one more time want to throw your Instagram in, I think anyone who didn't get their questions about SolidWorks answered, please shoot Rob a message. I'm sure he'd be happy to answer those. But Fong asked one more. What's the machinability of different resins? And that's a really great question. It really depends on the resin. The short answer is some of our materials can be safely drilled, milled, machined, and some of them I probably would avoid doing that. So I would say if you have a specific need in mind, contact our sales team and they'll talk you through what you're trying to do. Our sales team is really good about not selling you something you don't need. If our product isn't what you want for your end use, we don't want you to have it. We don't want you to waste your time and money. So just wanted to mention that. So yeah, I'll wrap up there. Trying to think of anything else to cover. I'm going to throw in one more time the link to the community roundup I mentioned earlier that we're doing on Thursday, same time, 12 Eastern. I hope you'll join us. I'll be doing a live stream on YouTube, totally free. Just hop on in. We'd love to see you there. Ask questions. Ask these general questions. Honestly, that's a great spot to hop in and just, hey, what material should I use for this project? I have questions about 3D printing in general. I would love nothing more than to answer all those questions for you guys. So let me toss this in here and we'll give that just a second. Rob, thank you so much for joining us. And thank you everyone for coming on and hanging out for an hour. This was really great. We had a great crowd, great questions. So yeah, any last words from you, Rob?
No, just thank you for having me on. This was super fun. You really have like a great crowd over here, and I hope to see you again, guys. So
yeah,
come follow me.
I think we'll have to do this again in some form or get you back for more Form Lab stuff for sure. So
yeah. This
awesome.
Isn't the last of me.
Well, with that, have a great rest of your week, everyone, and we'll talk to you soon.